5 cylinders. You simply can't find a replacement for that sound. The problem is they are often a challenging or expensive proposition. Or are they? And not many manufacturers made 5 cylinders. So is it possible to get that Audi Quattro rally car sound on any sort of an average guy's budget? In today's video, we challenged every single one of those questions, and we performed a turbo 5-cylinder swap with the highest produced 5-cylinder ever made. And we did it live on YouTube. Now, I will fully admit that I'm much more of an inline 6 guy, but I'm an open-minded guy, and I'm also a big fan of the GM Atlas series of engines. They came in a 4-cylinder, a 5-cylinder, and a 6-cylinder configuration, and it's time that we give the 5-cylinder an opportunity to shine. So will I be converted to a 5-cylinder guy by the end of today's video? Make sure that you watch till the end to find out. Day one, we started off with the conversion process, and the first part of that process was to remove the inline 6. Now, if you guys aren't familiar with the car that you're looking at right here, this is my 1981 Ford Fairmont, and it's been through a lot of stages in its evolution, and the most recent stage was with a Vortec 4200. It went an 893 in the quarter mile at, I think, 154 miles per hour. And since we plan to build a much faster 6-cylinder car, I think it's time to slow this car down a little bit and just have a little bit of fun with it. So we decided to pull that 6-cylinder out and give its little brother a shot. With the 6-cylinder now out of the car, it was time to start lining out the 5-cylinder, but before we installed it, we decided to do a couple measurements on the bell housing of the engine and sort of figure out some of the spacing with the bell housing to transmission and flex plate to torque converter interface. And we found that we were going to have some problems there. All right, so with the torque converter that I have right here, this is a Circle D torque converter. This is what we call the pilot. When Circle D made this torque converter for me, they made this a little extra long to account for the adapter plate. The problem with that is the crank pilot on the 5-cylinder, which it's a little hard to see, but down in there, right there, that diameter is not the same as a 4200 or an LS or small block. We need to make an adapter that goes from that diameter to the typical diameter that you see on a 4200. So we need to have room in there that we can do that. So we got 1 inch and just over 1/4 to the back of the crankshaft. So this is about even, 3/32, it looks like. So I'm gonna say that we're definitely gonna have to cut that adapter, the extension piece off. The fact that that sticks out 1 inch, just over 1.25 inches. So, yeah. That's going to be a problem. That's going to be a big problem. So remember that part where I said we might have to get creative? I think we're going to have to get creative. Now, I will say it is kind of difficult to be streaming live to a couple hundred people and run into issues like this. Frankly, I addressed the audience and said, hey, does anybody know of any bell housing spacers that might be commonly available? And then I proceeded to just completely ignore the chat. Okay, so we need a spacer, a bell housing spacer, for sure. What do people make? Anybody know of anybody that makes a 1-inch bell housing spacer? ICT Billet has something. I like ICT Billet. That's like one of my favorite companies. Do you have any bell housing spacers, Dad? I have to have one made. We'll figure that out, but do you have a bell housing spacer? Hopefully somebody has something that's readily available that they can take care or take advantage of
Can we just
economies of scale.
You have a bell housing spacer?
I don't have to pay one off.
You have a bell housing spacer.
Design what you need.
Because this is way into the. I mean, we can't even shorten that enough. There wouldn't be anything left.
I need 3. If we just put them, you know, one here.
Yeah, I mean, should I
adding
have I'm going to run into the
suggestions.
same problem with the.
The one guy said that
this part will come out.
But
Should
should
I?
but that's what centers your flex plate.
Then it's
You
going
can't
to
take
perform like crap.
Then you'd have to make a custom flex plate or modify that one. To the lathe cam, actually, this time.
No, hold on, I'm not ready for that yet.
Okay, build the 5
So, because this crankshaft is so far back, what we're going to do
Zip tie.
we're going to put a bell housing spacer
You got a spacer.
so that we can give ourselves a the torque converter is extra long on purpose because it's mid plate and it has extra length.
Quarter of an inch down at the most.
Got a game 4200 if you just
Good, good.
Yep. So
Check that out.
we got extra length back to the crankshaft, extra length. What are they coming up with? So this is part of the process, guys. It's just probably the stuff that nobody shows you. I apologize for that, but we did end up finding a bell housing spacer that was commonly available through Hughes, and we ordered one to be overnighted and get here as quickly as possible. Okay, will the 5-cylinder fit in place of the 6-cylinder?
That's a stretch.
I don't know, guys. If it doesn't, we're gonna lose the shop.
Okay. Are you gonna put an engine in here? Okay, stop.
Saying a 5-cylinder is not an engine? Need a real engine?
Well, that's one way to look at it. Hold on, hold on.
Scoot it here.
I know, but I want to make sure. Okay, so the oil pan, when it offsets and goes down, it only goes 1/4 of an inch. So you've got that. That's an interference that has to get fixed.
Where?
Right down here. See where the oil pan's hitting?
Yeah, but we gotta go back still. There. Now we're in the right spot.
All right. So 1/4 of an inch down at the most. Good, good. Oh my word! Check that out.
Like it was made for.
That's ridiculous.
Even with a 1-inch spacer.
You realize? You see this?
Yeah, look at that.
That's
You're
ridiculous.
not gonna have to make engine mounts. You can just rest it on there and put C-clamps in.
Yeah. Okay. Zip tie.
Yeah. Look at that. I mean, would you just look at it? It's like, fits around the steering rack, perfect. Fits around the K-member, perfect. And we got all this room for activities. Why didn't we do this sooner? Why didn't we do this at the start? Why didn't you guys tell me? All right, back to the sketchiest tripod in the world. I love that that's a thing. You know, I think that has to stay there the entire week. For day 2, my goal was to start figuring out my favorite part of almost any build, and that is the turbo manifold. I love building turbo manifolds, and to build the one that you're going to see on this engine, we wanted to emulate the Audi rally car program. I'm going to try and mimic how the primaries are laid out.
Oh no, another geek moment.
Yeah, I'm getting the whiteboard. Look out, guys. Okay, I'm not going to talk about thermodynamics or any of that gobbledygook.
No,
So don't worry about that. So normally with a manifold or a collector, if this is your collector and these are your tubes going into the collector, normally you would make it so that each cylinder would go with the firing order so that it would create a swirl in the collector, and it helps to scavenge the exhaust. But with that manifold, you can see that they did not do that. They had two cylinders crisscrossed with the way that they laid it out. So they were clearly going for something that was more
simplistic,
easy to fabricate and simplistic. So, you know, if you were to do it the way that, you know, would be a rotationally time collector, it would be 1, 3, 5, 4, 2, because that's the firing order of an Audi 5-cylinder. So they had it 1, and then this one was 2, because that made it easy, and this one was, sorry, this is not 1, this is 3, this is 4, this is 5, and this is 4, or no, 1, 1, 1, 1, 1. 1.
Yeah, they did it for physical.
So they just made it easy to fabricate. Also, we had to get a little bit creative with the primaries, and you guys got to see my great disdain for pie cuts. All right, I'm gonna be making a lot of pie cuts. I hate pie cuts. Eat one more pie cut, and I hate pie cuts. Did I mention that I hate pie cuts? Now, if you guys don't know what a pie cut is you either take a portion of a straight section or a portion of a curved section, and you cut it at angles where it can make a super sharp turn. And because we had to get the pipes down into the collector in a very small space, it required pie cuts. A lot of pie cuts. I mean, that looks good. So lines up real nice with the port here. Now I'm trying to keep this tucked away from here because I intend to run a tube up through here to this middle runner. So this one right here will also dive to this port right here. And that's going to require some pie cuts as well. And then this port down here, that will go up here. This one right here will go right here. Yeah, here. This one will go there. And then the bottom one, way down here, will shoot up and then into the center port. That should mimic the Rallycross manifold pretty good, but not bad for somebody who doesn't do pie cuts very often. And by the end of day 2, we had only managed to get one primary done on the exhaust manifold. This was not a great feeling. Frankly, I was hoping to get more stuff done on this project at a quicker pace, and I knew that if we didn't get it done in 9 days, it would be significantly delayed. In day 3, we continued to work on the manifold, and we pretty much had the same results as day 2. I only managed to get one primary done, and I continued to complain about pie cuts. As you guys saw yesterday, I was complaining about having to do all these pie cuts, but overall I'm happy with how it came out. The next runner that we are going to work on is this one right here. We're going to have to do some more pie cuts to get up to this port right here. Pie cuts, Calvin's favorite, right? Yeah, yeah, I love pie cuts. Yeah. So I'm going to make some more pie cuts so I can start my favorite thing in the world. Pie cuts. They're not my favorite thing. That was a joke. That was sarcasm. Don't send me pie cuts.
Evils wants to bring you more pie cuts.
I knew that would backfire. More pie cuts. Pie cuts here, pie cuts there, pie cuts everywhere. My worst nightmare. I'm surrounded by pie cuts. Ah! Got some pie cuts welded together. Now I can weld some more pie cuts. I love pie cuts. By the end of this project, I'm going to fall in love with them, I'm sure. Right, guys? Right? Yep, more pie cuts. Guess what?
Yeah, I love cherry pie, apple pie cuts too.
More pie cuts.
I should make one.
Ow, that is actually hot. Do you eyeball the pie cut angles or do you draw a line? Yeah, I'm pretty much just eyeballing it. Yeah, pretty much just eyeball the pie cuts. Yeah, I'm a big eyeball kind of guy. Like I I don't know, you can measure and like lay the thing out in CAD, 3D scan everything, and like come up with the perfect header ever made. And then you're going to go and try and cut it out and find out that you can't cut it accurately, and you're going to end up just fudging it anyway. So I'd rather just eyeball it and skip a couple steps, you know, skip the 3 months of engineering you would put into it to do it in the computer and just do it. Just do it. That is hot. See, if I wasn't so impatient, you know, I would like wait for this stuff to cool down before I picked it up. But why would I do that when I could do all 15 of them? Ow! Ow! That's hot! Boy, I hate pie cuts. They're such a pain in the butt. But we got the 2 hardest primaries done. And by the end of the day, I was tired of working on the turbo manifold. So I decided that tomorrow we would pivot to something a little bit more exciting. And that was the intake manifold. For the intake manifold, we decided to use a dual intake plenum style of intake manifold. And the reason for that is because we're trying to emulate the Audi Rally program, and that's what they used on theirs. Now, I could have fabricated this on my own, but that would have taken quite a bit of time, and there actually is a really nice kit out there produced over, in all places, Finland, where rally cars are extremely popular. So let's hop over to the live stream footage, and I'm going to explain how a dual intake plenum works. So today we are going to start on the intake manifold, and for that I gotta say a huge thanks to the guys over at MW Steel. They have supplied a really nice dual plenum intake manifold kit, and I have it laid out on the floor for you guys. You got their little logo here. It is a company out of Finland, actually. So I know that rally car racing is really, really big over there. And so they actually care about not just making the engine last for, you know, 8 seconds, 9 seconds. They actually need it to last for like minutes of wide open throttle. So they care about like cylinder to cylinder distribution. You know, that cylinder that gets a little lean, that you just, you're not wide open throttle for long enough. So who cares? You know, on a drag car, in a rally car, you gotta like actually, okay, let's fix this problem. We can't be running a cylinder lean for the way that they abuse their engine. They've developed this really nice kit with very thick aluminum. I'm not sure how they form this, I'll be honest. Like, this is really, really nice stuff. I don't know if it's rolled or if it's like hydroformed or something like that, but I mean, look at this. Like, look at how thick this stuff is. You know, this is I think it's 4 millimeter thick, which in freedom units, that would be, let's just measure it. So that's like 151 thou, or no, 157 thou, good number. You know, this is some thick stuff. That's like, yeah, that's almost 3/16 of an inch, which is what we normally pick for manifolds like this, especially when they have large flat areas like this. They do have some bracing that you can install optionally if you're going to run a ton of boost, which we're going to install, might as well. But really, really nice stuff. So this is a set of billet intake runners that we have developed in the past. Obviously, this is a 6-cylinder. We're going to end up cutting this cylinder off of the runner set, and it will work on a 5-cylinder. There are pretty much, the 5-cylinder is like you took a 6-cylinder and you took the rearmost cylinder and just deleted it. The goal here is to chop this billet runner set off, and then this plenum will sit on top of it, which we're going to have to shorten it slightly just to make it fit the engine a little bit better, which not a big deal. And then this secondary plenum, which, you know, has this very distinct tapered cone. This is the key to the whole thing. It goes, you know, off to the side. You can do it upwards, you can do it downwards, however fits your car best, which that's something we need to figure out. And basically this secondary plenum, the reason that it gets the dual plenum name, what this dual plenum does is this tapered cone uses a principle of science, fluid dynamics, where basically a tapered cone it distributes the air better as you move down the line. If you've ever looked at like large HVAC stuff, you know, where like in an industrial application, looked up in the ceiling and noticed how everything necks down and gets smaller as it gets further away from the air handler. I think this is the same concept. Basically, you know, normal forward-facing intake manifolds and even center feed intake manifolds, they deal with the problem where whichever cylinder is closest to the feed in the manifold, that cylinder gets fed the most air. And with this manifold, it makes it much better distributed through the manifold, and basically your cylinder-to-cylinder distribution of air becomes much more consistent. So it features this nice plenum here, all formed. I don't know how they do it, but it's a really nice stuff. And then on the back of the dual plenum, they have this nice formed piece here, which sort of caps off the end of the plenum. And yeah, it's really nice stuff. All right, this is gonna hurt. Sure you want to do this, guys? We could stop. We could just do a 6-cylinder. We could. I mean, we don't have to do this. We could just do the dual plenum intake on a 6-cylinder. I mean, come on. All right, I'm gonna cut it. I'm gonna cut it. I'm gonna cut it. I'm gonna cut it before I change my mind. Yep. Yep. We're doing this. We're doing this, guys. Yep. We're doing this. This is happening. This is a thing that is happening. All right. All right, here we go. All right, now this is the part where it like pauses and you may wonder how I got here. Ready? Right there. That's where. All right, here we go. Now we could just weld this back up. We could go back. I'm just saying. We could just weld. Should make this into a trophy or something. Make a 1-cylinder Atlas. There you go. 1-cylinder Atlas now. I'm gonna go full Rob Dom. I'm doing a 1-rotor. I'm doing a 1-rotor in a Miata. This better sound cool. What have I done? What have I done with my life? What events happened in my life that have led to this? We have strayed so far from God's grace. Nah, this will be cool. So it looks like fits in here pretty good. We actually got like a lot of room back here because of that 1-inch bell housing spacer. That was one complaint I had with the previous setup, is like squeezing my hand down in here to get to the bell housing bolts. Nightmare. So, all right, next we need to get our plenum. And we're going to have to shorten this a little bit because, as you can see, it's a little bit longer than the engine. So it will look something like that. And we're going to just cut a giant hole in this and then cut one of the ends off. We'll probably put the part that we cut off in the back because, you know, it'll look cooler if the front's all nice and continuous. taking brand new stuff and chopping it in half right here on the Nivlac 57 YouTube channel. So I think I'm going to weld the plenum completely together, and I'm going to make this weld the last one, because I think that would be the best way to do it. Does that not look sick? I mean, I think that is like the coolest intake ever, if I do say so myself. Alright, so throttle body is already down here because we had a center feed intake manifold on it before, but it should be pretty easy to rework our charge pipes, bring it in off of here. This still has to get cut off and shortened a bit, so that's still mock-up. Yeah, that thing's sick. We got quite a bit of work done on the dual intake plenum, but unfortunately we had a few issues during the stream. The stream kept cutting out as soon as I would start welding, and this was a little bit disheartening. I know what the issue is now, but during the stream it was a little bit hard to diagnose, and I apologize for that. But we did end up with a really nice piece by the end, and I gotta say huge thanks to the guys over at MW Steel for the beautiful intake manifold kit. If you guys are looking to build an intake manifold like what you see on this build, make sure that you go check them out. I will put a link down in the description. I know a lot of you guys were sold during the live stream that you had to have one of these kits, so make sure that you go check them out. So on to day 5. For day 5, we decided to build the engine. One question I received over and over on the live stream is, why did you use a 3500 instead of a 3700? Now, if you guys aren't familiar, the 4 and 5 cylinders received a displacement increase with their Gen 2 engine, whereas the 6-cylinder in the Atlas family stayed at 4.2 liters. Now, the 3500 and the 2800 4 and 5 cylinders had the same bore and stroke as a 4200, and since I didn't want to have custom pistons made for the increased bore on the 3700, I decided to stick with a 3500. Also, this gives us a little more head gasket sealing area, but we did decide to use a 3700 cylinder head on our 3500 bottom end. The reason for this is that the 3700, along with all the other Gen 2 engines, received a massive improvement in the cylinder head. The exhaust ports were much larger, they had larger valves, and they also had larger intake cams. So we decided to use the parts that we had commonly available, and also install the best of the best cylinder head to get sort of the best bang for your buck for building the best 5-cylinder that we could. Cool, let's get to work. So we got a couple of broken off head bolts that we got to mine out of here. We got 1, 2, 3, 4, 5 of them here. So let's do that first, because if we have issues with that, that's gonna kind of halt progress a little bit. Now, if you guys don't know, the Atlas engines, specifically the early 4-cylinder and 5-cylinder and all of the 6-cylinders, it's like they designed the bolts to break off. So we are going to mine them out with some extractors. Hopefully I don't make myself look like a fool today. I will zoom you guys in here and you can watch me struggle. Normally I do not center punch these because I don't want any chance of it mushrooming the fastener and making it harder to get out. So try to aim for the center. A lot of times you can get them out with just the left-hand drill bit, like I did with this one. Literally, you just drill into it, and the drill bit catches, and it comes right out. That's one. Got the second one. Came out with just the left-handed drill bit, because I couldn't even get it deep enough to use the extractor. All right, we got 2 out of 5. I can literally see the bolt flexing in the hole. It's that loose. Like, just about like stick a piece of chewing gum on it, twist it out. Got a third one. Number 3. You doubted me. Admit it. You doubted me. I know it. Alright. Our drill bit might be getting kind of dull. Let's use a different one. Alright, we're on the last one, guys. On the last one. This is where everything goes sideways. Let's try this one. Get a new one. So this is the one we were using earlier. All work, no play, makes drill bits dull. There you go. Right, that one is broken. Sheesh. That one's pretty dull. Alright, we'll try this one. Of course, it's always the last one that fights. Always the last one. Oh. Okay. We got it. God. This right here, that is what victory looks like right there. Alright. So we are gapping our top rings. We're going to gap top and bottom to 0.25 because that's what we've had success with in the past. And the engine that won 6 Summer was gapped very, very loose because we missed the target there on a few of those rings, and it's fine. If it's too loose, only you are going to know. If it's too tight, everybody's going to know. Okay, you're assembling an engine. Why the heck are you on a milling machine right now? Well, we actually make a modification to the Molnar rods to allow them to have a piston oil cooling jet, if you will, that basically helps to keep the piston walls from scuffing. The early rods have this provision, but Molnar didn't bother to duplicate it, so we like to add it. Alright, so this tool holds the rod for me so that I can just butt it up against the vise, and it will hold the angle for me so that when I clamp it, it's in the right orientation. Alright, see? Just got a little groove there, little groove there. And as the oil fills in here, it should hopefully spray out and lubricate the cylinder wall. You want to measure piston to wall? Let's do it. Even though I've already installed one piston and I kind of don't care, we can measure it because yes. Yeah, so this is how you measure piston to wall. This is called a micrometer. What this does is it allows you to measure things very, very accurately. So what we're going to do is we're going to measure. So you basically use this little thumb screw. This is like a little clutch. And when this gets tight enough that it starts clutching, you know that's... All right, lock that in. Okay, so we got our distance here. Then we get our dial bore gauge. All right, this is called a dial bore gauge. Basically, when you push on this little nub here, it moves this needle. It measures things super duper accurately. You're basically treating the piston like you're zero. You zero it against the piston, so you have this little extension piece here. Has a little spherical end, and then we take our micrometer that we've zeroed to the diameter of the piston. We stick our dial bore gauge in there. A professional engine shop, they would be doing this for every single piston and every single rod bearing and every single blah, 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 blah. I don't feel like it. I'd rather just put the engine together and see what it'll do. Okay, I have it zeroed out. You just have to trust me. All right, piston to wall. So we have it zeroed out, and you just rock this back and forth until you get measurement. It's 6,000. We ran 5.5 on the Sunbird. That's pretty loose, but it'll be fine. It'll be fine. Steve Jobs said, find a lazy person to do a difficult job, and you'll find the fastest way to do it. There you go. Yeah, the engine that we won 6 summer with had piston to wall clearance of 5.5. This one's 6. One of these days, I'm going to fire one of these up, and it's going to make the worst piston noise ever. You guys are going to laugh at me. Yep. Niv hack 57. That's a good one. I like that. That's a good spinning engine. Look at that. Look at that. All right, cylinder head time. So for the head gasket, we're just using a factory 3.5 liter head gasket because it matches the bore and does the job. So I have that sitting over here. Now we like to copper spray our head gaskets. All right, so our cylinder head is a ported head by our friends over at Snyder Performance. It is a 3.7 liter head. So let's get this thing flopped down on there. Ta-da! The last thing that we need to do to the 5-cylinder is delete the balance shafts. Now, as a matter of principle, I am vehemently opposed to balance shafts. How a balance shaft works is it basically generates a vibration that is equal and opposite to any vibration that the engine is generating. It's kind of like active noise canceling in your headphones, where it creates a sound wave, It makes it so that you can't hear any noise in the surrounding area. However, in this case, the engine is still vibrating, you just can't feel it. Also, due to the vibration in the 5-cylinder, these balance shafts have to be spun at double the crankshaft speed. And also, the vibration is only in the up and down direction. And when you have a balance shaft, it will generate vibration in the side-to-side direction because it's a spinning mass. Therefore, you have to have two balance shafts because you need the two balance shafts to generate an equal and opposite vibration to one another in the side-to-side dimension. So, in essence, what we have here is a mass that by design we have designed to be out of balance. And then we've decided, let's spin it double the crankshaft speed. So at redline, these balance shafts are spinning at 13,000 RPM. And as you can imagine, they take a considerable amount of energy to drive, and they wear out the bearings quite fast. So we're going to use a kit from a company called Badlands Industry in order to block off the oil passages, which will effectively delete the balance shafts.
This side of the crank, so the oil travels back through this galley, however you say it, right there. Then it shoots off as it goes down to the various locations down inside of here to lubricate the bearings where the balance shaft rides. Then the oil shoots off down here and comes into this cavity right here. And then the oil travels down the center of the balance shaft on this side and sprays out the sides. So with this side, it's super duper easy to delete this oil passage. You literally just put this plug in and it blocks off the passageway. On this side, it has individual feeds for each of those bearings, so we need to block off all three of them. So first we need to get the bearings themselves out that the factory installs down inside of there. So to do that, we are going to use this tool right here. So I guess we should show off the kit that guys at Badlands Industries has developed. It's basically these four components right here. And that will delete this and the three passages over here. Now, when we install these, I'm going to put some green Loctite on it. This is meant to seal off and make sure that things stay in location. It's called retaining compound. So we're going to use some of this in order to keep those in place. So we really don't want these rattling loose, obviously.
It smells funny.
I don't need that much, do you?
Uh-oh.
One more. Perfect.
Okay, it's out.
Yeah, we're trying to do the balance shaft delete kit. So it involves, and then there's some of these guys right here. And so Dad is trying to take the balance shaft bearing, which we just pounded out, put it on end, and then crush it so that we can pull it out top. There we go. They have, yep. Okay, hold that right there.
Yep, you got it.
Okay, grab a piece of welding wire. All right, guys. All efficient. Just fine. Got it. Done. We got a big one, guys. We got a big one. Hey, that's one.
Yeah, it's because the engine's
Oh, I got it on the first try. Hit it hard. Again. Oh, yeah. Yeah? Let's find out. Hey, buddy. Yeah, it's crushed. Come here, buddy. Doot, 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 doot. See ya. Wouldn't want to be ya.
Alright, now we just plump. There we go. We got it, guys. Dad is gonna coat the bearing, press tool, whatever thing, words. So we go. Yeah. And we can hold it upside down and it's falling out. Yeah. Green stuff applied. Alright, Dad is marking the depth that I need to pound it to. That way we don't go too far. Alright, that's number one. On this side. Good to me.
Done. Thank you, Badlands Industries.
Yes, sir.
You guys are pros. We're not.
We're idiots who can weld. Yeah. You know, a little bit of redneck goes a long way. Overall, the day went pretty smoothly, but the exhaustion was starting to set in. I realized that we were going to probably come down to the wire on day 9 of barely being able to get this thing started, but we had to just keep pushing and keep getting things done because that's what we do here. For day 6 and 7, I'm going to combine the two because they basically were both on the same subject, and that was wiring. Personally, I kind of hate wiring. It's one of those things that once it's done, it's super satisfying, but while you're doing it, it kind of sucks. So I basically sat in my lawn chair and worked on building a brand new wiring harness for this car. Now, a lot of you in this stream asked, why couldn't you just reconfigure the ECU and just plug in the 6-cylinder harness? And I could have done that, but I decided not to because this car has been through so much. We've had many different ignition coil setups, many different injector setups, many different crank sensor setups on this car, and it was in need of some TLC, and basically it was better to start with a new wiring harness and just, you know, start over. This also allowed me the opportunity to sort of explain how we do our wiring on our cars and, you know, kind of demystify it a little bit. So if you guys haven't seen it, this piece of jewelry just showed up in the mail. This is a Colorado 5-cylinder pan that has been modified by the guys over at Atlas Industries. Super nice job. I mean, the welds on this thing are incredible, and I'm super excited to get this thing thrown onto the engine. It should increase our oil capacity from 6 quarts to 9 quarts, and if you guys have been following us for a while, you know that we like to have a little bit of more oil capacity in these Atlas engines, just because sometimes the oil likes to get trapped up in the head. So before we install the oil pan, we got to put in a pickup tube. All right, so this is just a factory Colorado 5-cylinder pickup tube. You got to be careful because some of the early ones had O-rings instead of this gasket style connection here in the front. I just bought this right off of Rock Auto, I believe. Alright, so we got our pickup tube on. I got it nice and torqued down. We don't have to re-drill any holes because it's a 5-cylinder and it's meant to go on this engine. I know, crazy, right? All right, we are putting silicone onto, well, it's RTV, whatever you want to call it. Ultra black, RTV, onto our oil pan. Thanks again to Atlas Industries. If you guys are looking for anything Atlas related, go check out Atlas Industries. Chances are they might have something cool that you're interested in. Okay, squish. Okay. Getting our really, really fancy Atlas Industries oil pan installed. He even did our turbo drain for us. Now on the latter half of day 7, I decided let's drop the engine in for the final time. And this took way longer than I was expecting. We ran into probably the hardest issue to overcome throughout the entire live stream. And I thought we were through the worst of it with the bell housing spacer, but it turned out that the flywheel to torque converter interface, being able to bolt the two to one another, turned out to be a lot more difficult than I was expecting. And by the end of the day, I was having all kinds of doubts on whether we were actually going to be able to get this project done. We've been having the same issue with the North Star build that we're doing on another project, which you guys should go check out if you're interested in weird engine swaps. And it was a major source of a little bit of anxiety. I spent an entire week trying to fix this problem on our other build, but it kind of turned into this blessing in disguise. If I had not encountered those issues with the North Star, frankly, this project would have been screwed. This right here, this is like a $2,200 to $2,500 torque converter. And these are some lug nuts. And today, they will become one. On day 8, we came in with a clear head and a solution to our flex plate to flywheel situation. Now, a lot of you freaked out when I said we were going to weld some lug nuts to a torque converter. Are you really going to weld that nut to it? I thought you were... No, we're going to do that. That is happening. We're doing that in like a very short period of time. That is happening. Have you measured the welding filler to and tried to... No, I'm not, dude. I'm just gonna weld it. It's gonna be fine. It's gonna be fine. I'm just gonna weld it. And you guys said, what about the balance? If you weld anything onto that torque converter unevenly, it was going to create all sorts of imbalance just because of uneven weights around the rotational center. All right, what we have here is a plate that I made for the North Star to adapt from a more typical like Turbo 400 flex plate pattern to the North Star pattern. So if you have a torque converter and it's bolting up to this here, normally the torque converter pad sort of covers this area, and I was worried that if I had a bolt that was a little too long, it would hit the torque converter. So I originally drilled the holes for the adapter here, but I was like, you know what, I should offset it a little bit and leave myself a little bit of room so that the bolt can protrude a little bit and not hit the torque converter. Well, these holes here are actually going to help us a lot today because these 3500s have the same flex plate pattern as the North Star. So we're actually going to be able to use this as a jig to hold our lug nuts in the correct orientation, and with a little spacer here, and we can screw our lug nut on. I did weigh the lug nuts. 2 of them were 47 grams, 1 of them was 48. It'll be fine. So we can use this as an alignment jig. This is already set up for a the diameter on the LS small block, big block. It's already set up for the 1.700 crankshaft register. So this will register on the crank pilot for the torque converter that we have, and then this will help us to center everything up, and then we'll butt it up against the lugs that are already on the torque converter. So if we have issue with a weld cracking or anything like that, it'll still be butted up against, and then we're going to weld it to it. It's going to be fine. Actually, it's 7/16 fine thread. So yeah, we're just going to weld right over that. That's not a serial number. All right. Yep. And then we're gonna weld it.
But I would only weld a little bit and then walk away from it and then come back and weld a little bit more.
Yeah, we're going to have to do it in small stages because there is a torque converter clutch inside of there. I don't want to overheat that junk.
Yep.
Because That thing was really expensive, and I don't want to mess it up. With that solved, it was time to finally be able to install the engine into the chassis, which frankly was overdue. I wanted to have the engine running and be able to let you guys hear what this thing sounded like in less than 24 hours. And it was starting to look like that was going to be an extreme challenge. But we don't give up here. So, on to day 9. Day 9 was pretty much a mad frenzy. It was wrapping up everything that we had left hanging. It was finding new issues that we had to solve and solving them as quickly as possible. Now, this past week had been a lot of work, a lot of 14, 15-hour days, working into the early morning and then waking up the next day early and getting back to work. The exhaustion was really starting to weigh on me, but I wanted to get this thing done and I wanted to prove that we could do this. Off stream, we had finished the exhaust manifold, and on stream, we finished up the intake manifold. And we began to piece the car back together until it was time. And we ran into another issue, which frankly I need to correct. In the last video that we did on this car, we said that the firing order was different than the Audi. And so I put that firing order into the ECU and we went for our first start. As you could hear, that didn't go well. But a lot of you in the comments were saying, no, it's 13542. And well, we found out that you guys were right. And this engine does in fact have the same firing order as an Audi 5-cylinder. So the question was, will it start? He can't even say it. Yes! And we were victorious. I gotta say, thanks to everybody for tuning into the live stream. It was a marathon effort, but that is not where this video ends. We had a lot of ups and downs. We struggled our way through. The engine ran, and we did it live. But the car still was not ready for some boost. So this past week, I have spent the time getting this thing wrapped up, and we finally got to the point where we could take this thing for a drive and see what it sounded like. So we did just that. Now there's one last question that we have to answer in this video, and that is, am I a 5-cylinder convert? Now let's just briefly go over a comparison of the 5-cylinder and 6-cylinder as far as a pros and cons point of view. The 6-cylinder is quite a bit easier to swap. You don't have to deal with those dumb issues with the flex plate to torque converter interface, or the pilot adapter or anything dumb like that. You don't have to deal with balance shafts on the 5-cylinder that need to be deleted in order to make the engine less prone to failure. The 5-cylinder has less cylinders to spread the load across, but the sound. Frankly, I gotta say, I'm very happy with the sound of this engine. I think we hit the nail dead on the head as far as the sound that we were after with this build. But is it as good as a 6-cylinder? That's the question. Frankly, the reason that I was hitting the rev limiter so many times in those driving clips is because my ear is very much trained for a 6-cylinder. I expect a much higher pitch sound before it is time to shift, and that was definitely throwing me off. That being said, these definitely have a unique sound, and I gotta say I do like it. I do like the sound, but for me, I'm still a 6-cylinder guy. I'm sorry, guys. I'm really happy with the swap. I don't think we're gonna take it out anytime soon, but variety is the spice of life, and you can have two favorites, one being more favorite, and I'm happy that we did this swap, but there's definitely one that I like a little bit more. So with that, make sure that you like, comment, and subscribe, and we'll see you in the next one. Real quick, before we end this video off, I have some shirts to promote. We had quite a few shirt-worthy moments during the 9 days that we live stream. The first one is the Niv Hack 57 shirt. You guys got to see us do some hackery, and let's face it, we can all be hacked sometimes, so let's celebrate it. Next is the 5-cylinder firing order shirt. As you guys know, I got the firing order wrong, and we did find out that it was the same firing order as an Audi, so we thought we would memorialize it. The last shirt is actually one that's a little bit overdue. This is to celebrate our win at Six Summer, the Sick Week Freaks class. You can see the orange helmet, and of course the Sunbird, the car that we won the class with. So if you want to support the channel, this is a great way to do it. Thanks for all the support, guys. See you in the next one.